Hello students, welcome to my physics class. Today we're going to be talking about kinetic energy and work. So what is kinetic energy and what is work? I'm going to be going over those basics, nothing more in depth. There is gravitational kinetic energy, or gravitational forces and spring forces and variable forces, but we're not going to be going over that. It's only the basis of kinetic energy explained and the basis of work explained. That's pretty much what we're going to do. So the first thing we're given is kinetic energy, right? And the key idea of this chapter, chapter 7, is A, which is kinetic energy, equals to 1/2 mv squared. So let's write that over here. A equals, this is an easier way of rewriting it, which is mass plus v squared over 2, right? Where m is the mass, and it's usually in kilograms, right? And velocity is in seconds. And whenever you get that out, you're going to receive your answer in a measurement of joules, which will be given, right? So pretty simple. I'm gonna be going over an example problem real quick. So let's say, let's come here. Let's say you have Gunner, right? Gunner has a health of 80, right? So we'll have that as his mass, and his speed is of 35, right? We'll have that. So we'll plug his numbers into the formula for kinetic energy. We'll have 35 squared, which is 35 times 35, 125 or 1225 times, I think 80 was the speed or the mass, yeah, times 80 divided by 2. We have a kinetic energy value of 39,000, right? This answer will not be in joule, so we'll say blocks will be the measurement we have here. So that's how you calculate kinetic energy. Pretty simple. If you have grams, use your conversions. So I think it's by 10 to the negative third or 10 to the third, I forget. You gotta search that shit up. But yeah, if you're doing grams, it's grams times 10 to the negative third or positive. I don't know. You gotta figure that shit out yourself. I'm not doing that. But yeah. So you calculate kinetic energy. Pretty simple. Yeah, it just tells you what I just said. Joules, yeah, kilograms, meters per second. Oh, my mistake. Oh, I'm a goofer. Meters per second is the velocity. My bad. Right? Joules, more stuff we don't need to get into. Now we're introduced to work. So work is FD cosine theta. Theta is just degrees, it's just a placeholder variable. For F, right, it's usually written like this, is the force, and it's usually written in newtons. N, you have D, is like this, which is your displacement. You just think of it as as a difference or the length between the two, or the. We'll just do an example and you'll see. But let me get another subject here. We'll have a thief, right? Um, actually, no, we're not. Actually, yeah, we'll use thief. So thief is right here. No, he has his knives. He throws his knife, right, with a force of 100 newtons, right? That's the force he used to throw. Like, this is his hand just going out after throwing the knife. 100 newtons of force. The knife is flying this far. This is where the knife is right now, right? And the distance from here to here is the displacement. We'll say in Roblox terms like 15 studs, right? Displacement. So the formula for work is force times displacement, right? Force is times displacement times cosine theta, which is at an angle. You only add cosine when you're doing an angle. But here is just a straight line, so you do not need to add cosine, right? All we do is just multiply these two. 100 times 15 is 15, and then 2 zeros. Pretty simple. You get 15,000 is your work. But you'll have your measurements also in joules. So, we'll just write blocks. Yeah. Keep it simple. So this is your work. W equals this. Right? But let's say, we have Hummer. Right? You know how he throws his bombs arching, and then they go back down. Stuff like that. All we don't need to find this whole thing out. This is gonna take way too long. It's kinematics. I forgot the formula. We're not gonna do that, but all you need is the force used, right? The force, your F value, displacement. So this displacement is right here. We'll say that's 10 studs, right? 10 studs. The force used, we'll keep it 100, 100 newtons. And this angle, we'll say it's 45 degrees, right? Just keep it plain and simple. So what you do is the force, which is 100, times your displacement times 10, and then times cosine of theta, when theta, or the variable degrees, is 45, right? And you get your work for that. But I'm not trying to do all that, because I'm not trying to do cosine 45. That shit is too much work. But I'll just tell you right here, your work is going to be a positive number. Why, you ask me, that is? We'll put this, let's pretend this is a graph, right? I'll tell you why it's positive, your work. And this is a shortcut too. If you're just asking or given a question, right? Is your work going to be positive, negative, stuff like that? I'll tell you right now. So if you're going in this direction, your force, no, forgot. No, but yeah, if your force and displacement's this way, right? But your angle is within 0 and 90 degrees, right? Your work will be positive. If it's between 90 and 180, your work will be negative, right? What happens if it just goes straight up 90 degrees, right? It will be positive, negative, or just be 0. No. What are you gonna do? Can't do positive, negatives, it's just 0. Another shortcut you can use if you want to find work and you don't have like your force, right? And you only have your kinetic energy. You can just do it as that. And the formula for that is work equals kinetic final, your final kinetic energy minus your kinetic initial energy. Right? And we have this example right here of Gunner, with his kinetic energy being 49,000 blocks, right? Let's say that's his final. That's him moving at his speed, which is 35, right? Let's say his initial. Let's say, so the final is right here, right? Is this number right there. Has initial, right? If he's initial, what would he be? Right? What's his kinetic energy at his initial point? So at his initial, he's just standing there. He's not moving, right? So what do we say about his speed? If he's not moving, his speed is gonna be 0, right? When we 0 times whatever, it doesn't matter. It's gonna be 0. So his kinetic initial, we're doing it in terms like this, it'll be 0, right? So if you subtract these two, it'll just give you your kinetic energy again, right? You can also think of your work as equal to the change in your kinetic energy as well. Even simpler. There will be examples when that's not the case. I'm just saying this as an example as a linear terms in 2 dimensions. I'm not talking about 3-dimensional yet because I'm not trying to do all that, but pretty simple. I should be, and I think that's work. the kinetic energy final was I already explained that. Then the change, I already explained that. Also your F, right? If you need F and you can't find F, right? F is equal to your mass times your acceleration, right? So, for example, right? You're given acceleration in a problem, or acceleration in a car, you just put that in as a value. Let's say, hey, what if there's no acceleration? What if it's just falling down, right? Replace A with G, which is gravity, which is equal to 9.8. Or if you have not this, or you're not given an A, you have to use kinematics. And I'm not trying to do all that, so you know, you can search that shit up yourself, buddy. I'm not doing all that for you. But yeah, look, kinematics right here. Yeah, so you see A right here. What you can just do is use this, put A by itself, find A, but yada yada. You know, I'm not doing that shit for you. You can do that shit yourself. But um, that should be it. Yeah, because gravitational force is next. This is basically just potential energy. I'm doing kinetic energy. Um, yeah. So yeah, my lecture's done. Make sure you like and subscribe. More physics lectures coming soon. You know, I'm just that good, and I'll see you guys later.